Alright, welcome to the very last case for add. So, to add, this is going to be unfortunately just the slightest bit of a hassle to do. But that's what we'll do. So, first off, like we've done before, we are going to remove these whole head and tail variables, right? Because those don't really make sense in these contexts here, right? Instead, we are going to deal with I minus 1, the index before we want to add to, I, the index we want to add to, and then we want to deal with I plus 1, right? So we want to insert a node in between I minus 1 and I. In other words, we want to insert a node at index I, so that will go between I minus 1 and I. Boom. Okay, so here's our node that we want to add. And I'm going to give myself some more space to draw. Okay. Okay, so the first thing we're going to have to do, like usual, and first I'm going to draw this, then I'm going to do it line by line and draw it, and remember I'm going to be doing arrows from the top over here. Over here they're going at the top they're going to do dot next, and at the bottom they're going to do dot previous. So first thing that I'm going to do for adding this new node is I'm going to attach it, well first, right, before I can attach anything I have to have a way to refer to any of these nodes. So I'm not going to get this node, although I could in this because I have a way of moving backwards, but simply to keep it symmetrical with the other stuff we've done previously, I'm just going to go ahead and get the node before the one I want to add, just to keep it the same, as much similar as what we've seen before in the singly linked list, right? So first thing I have to do is get the index before this one. Okay, so I'm going to attach to before.next, and I'm also going to attach to, but I'm also going to make before this node's previous, right? Going to attach him. I'm going to basically set up these two pointers so that they're pointing to the correct thing. Okay, so now that that's done, it's actually kind of nice. By doing this, I basically cannot lose my linked list in any way, so long as I attach this guy first correctly. Okay, now I have to adjust these pointers to point to the same thing. So I need this pointer to point to here. I need this to point over here, and I need this, the guy's dot next, this arrow to point to here. Now remember, this arrow is somebody's dot next. This is my dot. This is temp dot next, right? This is this guy's dot previous, and this is my dot previous. Okay, so that is important to keep in mind. The question is, a lot of the times for this one, what's going to make it difficult is the question of how do I refer to what these arrows are, right? Oh, and completely and totally messed up apparently. How embarrassing. Egg on my face. Alright. Alright. Let's go ahead and start again. View to distraction-free mode. Alright, so the first thing we've got to do, we've already got this node established. We want to get the node before the index we want to insert, so we'll say node E before is equal to this dot get node at int index minus 1. And again, you can actually feasibly do this from int index. It just becomes, well, a bit weirder. And again, this getting the node beforehand is safer. It deals with it prevents a lot of issues with actually, yeah, I just like this way better. Okay. Because this route and this route help us deal with potential, again, no pointer exceptions we might otherwise encounter. Alright. So first thing I need to do is attach temps.next and .previouses to the right place. So I need to attach it to this node. Now what is the node at index, or index I in this case? It is before .next. It's resolved by looking at before.next. So temp.next, we're going to store inside temp.next the node that's being stored inside of before.next, or the memory location of the node that's being stored in before.next. All right? So what about temp.prev? What is that going to be? Which node? Well, we need to store inside temp.prev this one over here, but that is before. So we just put down before. That's simple enough. All right. So now we get complicated. Now the complicated bit depends on like how we do these things. On what order we do these things. What order do we move these arrows? Do I move the top arrow first, or do I move the bottom arrow first? And that's going to basically affect the way we do these things. So let's say we move this top arrow first. Okay? So I'm going to move this over here. This top arrow over here. What is this arrow? This arrow is before.next, right? It's before's .next pointer. And I'm going to have it point to what? I'm going to have it point to temp. Okay? Now I need to move this arrow over here. So what is this arrow? Well, I have before over here, and I also got to remember that this guy can refer to him as temp. So this arrow is this guy's .previous. So it's so that arrow is somebody's .previous. All right, whose .previous is it? What is this? How can I refer to this guy? I can refer to this guy as temp.next, right? Temp.next.previous. That might seem a bit weird, right? Shouldn't that like cancel itself out? But temp.next resolves to him, and we're saying I'd like to store something in this guy's variable. And we're saying that basically that what we want to store in there is temp. And that should do it. Say, right, how did we get this arrow? Well, it was from this guy, which is temp. So how do I refer to this node? Temp.next and his .previous arrow. All right. So that we'll now test by adding in a and then an E at index 1. Oh, index 0, because I said index 0. Oops, that didn't update like I wanted it to. And it seems to work just fine. All right. So that's it for the add method.